So when we use all of these variety of indirect operands in our instructions, two things are happening. We are computing the memory address. That's number one. And number two is that the assembler has to be able to know what is the size of the operand that we're trying to access or modify. So there could be essentially these three possibilities. So let's just try continue using our table sample right here. I'll just copy and paste these three. Primarily we're looking at the syntax, not any kind of logic in this program, just plain syntax possibilities. And also note that because I'm using randomly these registers, just simply testing if assembler will be able to process my source file. Don't try to execute this program. It's not going to work very well because I have no idea what this EBX register contains. Whatever. I'm just trying to focus on the topic of specific syntax that is available. And so let's talk about these three possibilities. So number one, if we use this syntax, we have our table. This is a table of 16-bit integers, words. The word on x86 platform is a 16-bit word. And this first example, it's trying to store 0 in whatever element specified by register EBX. But at the same time, this table is table of words. So in this case, 2 bytes or 16 bits will be updated. And so the size of the operand is derived from the size of the definition of the table. Assembler knows the this table is an array of 100 words. So this is why the 0 will be updating 2 bytes, which is the size of the word in memory. The second situation is that we can override this data type by simply saying that we want to use byte as a destination and not 2 bytes. So we can just override this. And here again, every time, although this syntax is possible, my preference is to use square brackets whenever I write code to access memory. It's just, it's not just style, it's so much easier to read the code when you have some consistency using square brackets, because sometimes you don't know what this is. It could be some kind of constant, it could be definition of memory allocation, so it could be different things. So whenever I use this, I'm pretty clear about what's going on. It's just basically the same thing. We're trying to access an object in memory. So that's the purpose of using square brackets. So that's why I added my own square brackets to the original example from our handout. And the third example is that we try just address of whatever's in EBX, and we say let's go to object at this memory location, and let's load this into register EAX. So this time the size of what is in memory is determined by the size of the register. Of course, you can still do the same thing, and you can say word pointer. Okay, so you can be explicit like this, but you don't have to be. I don't know if it's your style, you can use this, but most people just shorten it to this because it's obvious that the target is 16-bit. Therefore, we're apparently trying to get 2 bytes out of memory and store it into 2 bytes inside this inside this lower half of the EAX register. And also indirect syntax options is just basically different formats of syntax. So let's just copy and paste this and verify that in our in our version of our assembler, all of this, by the way, all of this means the same thing. And again, I'll just rewrite. This was apparently tried on in 16-bit real mode, using 16-bit mode, but I'll just use 32-bit registers to switch to 32-bit mode, and just to test whether all of the syntax will hold properly, and just to see if everything is going to. I'll just add some spacing here to make things more readable. This is my return instruction on the next line, so once again, so these are all the possibilities trying the same thing. So let's give it a try. Okay, and we build. Okay, so everything builds fine, and so these are all the possibilities. It's really whatever your choice is. I would just probably choose one of the two of these at the top, because they sort of like, you know, look like a multidimensional array. But depending on the logic of your program, maybe this just meaningful expression, maybe it's not related to a multidimensional array. So it's, again, this is your decision which style to use. It all depends on what comments are you going to add to these formats, but it's exactly the same instruction. And again, if we like set a breakpoint here and start a debugging session, and just take a look at the disassembly view of this, it is all quite visible that this is all gets resolved to the same exact instruction, which is built right here. Well, actually, there are some variations. This like mode RM byte is using two different versions here, because we switch around with the registers right here, EBX plus EDI or EDI plus EBX. Right, so there's this basically only here there's a twist, but the instruction actually is doing the same thing. Okay, so but these are all the same, logically the same instructions when we try running this program. All right, so just going to stop debugging session, and so this is our overview of these indirect addressing modes with displacements and different syntax options. The bottom line is that if we have multiple square brackets in whatever operand format we're trying to apply, it is simply this. It's always just a combination of the three things: your registers and displacement that you add to here. By the way, it's not possible to add a third register. Okay, if you try something like this, let's say ESI, okay, whatever, right? So we just try this. It is going to tell me that multiple base registers are not allowed. So this is not going to go very well. So there's a limitation. Two of them combined are okay.